Okay, this problem right here is basically a review question, and I can't give a whole lecture on just SN1 and SN2 to, then identify all of these different things, but I'll mention what I can here in the video to make it rather short. So a one-step reaction is, you see these letters 1 and 2 don't correspond to the number of steps. They're reversed. Okay, so that's one thing to kind of remember about this. So a one-step reaction is actually SN2. Okay. Favors strong nucleophiles. That's SN2 as well. Remember how for an SN2 reaction, you have a simultaneous smacking of the nucleophile into the carbon to kick off the leaving group, right? And you want that nucleophile to be negatively charged, very strong, for this reaction to go well, okay? Racemizes the stereochemistry. That's SN1. Remember, if you have a structure with a very cool looking alkyl halide with a wedge on there, and when this leaves, you form a planar carbocation that is planar, and when the nucleophile attacks, it can come from the top or it could come from the bottom, and that gives you the nucleophile installing from a wedge or a dash. So we call that racemization. Okay. Second order kinetics, that's easy to remember. That's SN2. That's what the 2 there means, right? E has a carbocation intermediate. We just talked about that with part C. That's your SN1. Okay, SN1 reactions have a carbocation intermediate. Okay, best in protic solvents. So that's going to be SN1. Okay. Again, you have these carbocation intermediates that are going to be solvated by protic solvents. Okay. Two-step mechanism. That's going to be the SN1. The summary is down here in green on the bottom left. H is going to be inverts the stereochemistry, and that's going to be your SN2, as we know. First order kinetics, that's of course SN1. That's what the 1 there means, right? And best in aprotic solvents is SN2. So, I'm sorry, it doesn't look like I'm teaching you much here, but if you're just looking for the answer key or viewing things, these are the answers for this type of question, okay? Thanks for watching.